Okay, today we are looking at the very last topic of chapter 4. So we are looking at topic 13, so chapter 4, topic 13, and we are looking at the quadratic equation, the quadratic formula. Quadratic formula is a formula that has been derived to allow you to find the solutions to any quadratic equation without using any method at all. So we learned how to use completing the square, we learned how to use factoring, we learned a couple of different methods to solving quadratic equations. A quadratic formula is just a formula that will provide those solutions without using any method. The only initial condition necessary is that it's in standard form and equal to 0, and a is not negative. So if we look ax squared plus bx plus c, where a is positive, and as long as we identify the a, the b, and the c, then we can use the quadratic formula to solve this equation. The quadratic formula is x is equal to negative b plus minus square root b squared minus 4ac all over 2a. Now, there is an important part of this formula, this b squared minus 4ac part. This is called the discriminant. And this part can be used to determine how many, can't really read that. This discriminant can be used to determine how many solutions that this equation will have. Because remember, quadratics can have no solutions, no real solutions. It can have two real solutions, or it could have one real solution. And sometimes the solutions can be complex, in which case it would have no real solutions. So that is the discriminant. If the discriminant b squared minus 4ac, if that's larger than 0, then it will have two real solutions. And if that discriminant value is less than 0, then it will have no real solutions, which would mean both of them would be imaginary. It would have no real solutions. It would have two complex solutions or two imaginary solutions. And if that is equal to 0, it will only have one real solution. And you'll see that play out because you can think about it because it's under a square root. If the value under the square root is negative, then of course, if it's less than 0, then of course you're going to have complex solutions. And if that value is 0, then this whole part disappears. So you would only end up with one real solution. All right, let's practice using this formula to solve some quadratics. So this is equal to 0, and the a value is positive. So we can use it on this, 1, 7, and 5. Our formula, negative b plus minus square root b squared minus 4ac, all of this over 2a. All right, so our equation, our formula becomes negative b, so negative 7 plus or minus the square root b squared, so 49, minus 4 times a times c, so 4 times 1 times 5, so minus 20. All of this over 2 times a, so 2. All right, so this requires some simplifying. So let's simplify first under the radical, so plus or minus the square root of 29, because 49 minus 20 is 29, all over 2. All right, we could technically leave it like this. I guess that would be okay. Negative 7 plus minus the square root of 29 over 2. can't really be simplified any further, so would be okay. Another way to simplify it, we could, theoretically, distribute the 2 to each of those. So we'd have negative 7 over 2 plus or minus the square root of 29 over 2. This would be another way to write it. All right, either one of these ways are fine. Either this one or this one would work. Both of these are fine. Just keep in mind this represents two solutions, one where the square root of 29 is added, and one where the square root of 29 is subtracted. Okay, so it's two solutions. Number 2, it's not in the proper form yet. The 16 needs to be on the other side, so we'll subtract it. So we get x squared plus 6x minus 16 equals 0. All right, we're going to use the formula negative b plus minus square root b squared minus 4 times a times c all over 2a. So our a is 1, so that's fine. B is 6, c is negative 16. So I'm going to plug each of these, or substitute each of them into the formula. So x is equal to negative b, so negative 6 plus minus the square root b squared, so b squared, 6 squared is 36, minus 4 times a times c. So 4 times 1 times negative 16. So 4 times 1 times negative 16 is negative 64. That is going to become plus 64 in just a second. All over 2 times a, so all over 2. All right, and now we have some simplifying to do. So negative 6 plus minus square root of 36 plus 64, which is 100, all over 2. All right, this can go further because we can take the square root of 100. So this becomes negative 6 plus or minus 10 over 2. All right, this can still go further because all of this can be simplified. So we're going to have two solutions, negative 6 plus 10 divided by 2, and negative 6 minus 10 divided by 2. And both of these can be simplified. So negative 6 plus 10 is 4, and 4 divided by 2 is 2. And then negative 6 minus 10 is negative 16, and negative 16 divided by 2 is negative 8. So there's my two solutions to number 2, which would be 2 and negative 8. This quadratic formula is really just a last resort kind of thing to find the solutions. This is by far the last possible way that you would want to do this. If you could factor this, you would want to factor this. If you could complete the square, you'd want to complete the square. All right, let's look at some others. So number 3, well, we got to get that 25x to this side. So our equation becomes 2x squared plus 25x plus 33 equals 0. So our a is 2, b is 25, c is 33. So let's use our quadratic formula. A is 2, b is 25, c is 33. A is 2, b is 25, c is 33. So our formula is x is equal to negative b, so negative 25, plus or minus the square root of b squared, so 25 squared, I don't know what that is, 625, so b squared minus 4 times a times c, so 4 times 2 times 33. which is 264. All of this over 2a, so a is 2, so 2 times a would be 4. Alright, let's simplify this a bit. So negative 25 plus or minus the square root of 625 minus 264, which is 361, all over 4. Alright, I do not know if 361 has any prime factors. Um, 361 divided by 7. 1 divided by 8. I don't think 361 has any. No, it is. It's a perfect square. 19 squared. So it does have perfect square factors. 361 is 19 to the second power, or 19 squared. So the square root of 361 is 19. So we get negative 25 plus or minus 19 over 4. Now these can both be simplified. So we're going to have negative 25 plus 19 over 4 and negative 25 minus 19 over 4. So negative 25 plus 19, negative 6. So you get negative 6 over 4, which reduces to negative 3 over 2. So our first solution is negative 3 over 2. Our second solution is negative 44 over 4. And that also reduces to negative 11. So our two solutions, negative 3 over 2 and negative 11. All right, let's take a look at number 4, x squared minus 4x plus 13. This one would be way easier to solve by completing the square, but we're doing it this way, so we'll use the quadratic formula. A equals 1, b equals negative 4, c equals 13. Alright, so quadratic formula, x equals negative b. B is already negative, so that becomes positive. Plus or minus the square root, b squared, so 16 minus 4 times a times c. So 4 times 1 times 13, so 52. All over 2a, which is 2. Alright, let's simplify this a little bit. Plus or minus, whoops, sorry, skip to the 4. Plus or minus the square root, 16 minus 52, negative 36, over 2. Alright, so this can still be simplified. We have 4 plus or minus 6i over 2. Alright, this still needs to be simplified because it's imaginary, or it's complex, which means that the 2 needs to be distributed to each part so that I can see which part's real and which part's imaginary. Or which part's, yeah. So I would have 4 over 2, which is 2, plus or minus 6 over 2, which is 3, so 3i. Alright, so this is two complex solutions. One of them is 2 plus 3i, and one of them is 2 minus 3i. And those are my two solutions using the quadratic formula. Like I said, the quadratic formula is by far the least effective way of doing that. We could have just as easily completed the square and got the same thing. And the quadratic formula is actually derived from the process of completing the square. Alright, so the homework for this one, page 56, 4, 7, 8, 13, and 14.